Okay, in this lesson, we're going to be talking about proportional versus non-proportional relationships. Okay, for a relationship to be proportional, it must have a constant ratio. We often call this the constant of proportionality. If they do not have a constant ratio, then they are non-proportional. Okay, and to find that COP or that constant ratio, we would take our y value and divide it by our x value. In a table, the x value comes first and the y value comes second, as you can see here in this table. X and then y. Okay, so let's look at our first example. The cost of one CD at a record store is $12. Create a table, which there is, to show the total cost for different numbers of CDs. Is the total cost proportional to the number of CDs? So we're looking, is the number of CDs going to be proportional to the cost of the CDs? You see our X row here is the number of CDs, 1, 2, 3, or 4 CDs bought. And down here in the second row, the Y's are the cost of those CDs. If I buy one CD, it'll cost $12. 2 CDs will cost $24. 3 CDs, $36, and 4 CDs will cost $48 because they're each $12. To find our ratio, or our COP, we take our Y and divide it by our X. So 12 divided by 1 is 12. Y divided by X, 24 divided by 2 is 12. 36 divided by 3 is 12. And 48 divided by 4 is 12. Since they're all the same value, since the COPs are all the same, then we can consider this one to be proportional because they're all the same constant ratio. This tells us that each CD is $12 per CD, right? From unit rate, that was then $12 per CD. Okay, so our COP is 12. Our equation then would be that y equals 12x. Remember that y equals kx. We replace the k with our constant of proportionality. Let's look at the second example here. The cost to rent a lane at a bowling alley is $9 per hour plus $4 for shoes. Create a table to show the total cost for each hour of bowling if you've also rented the shoes. Remembering that this is our x and this is our y. If I went to the bowling alley for 1 hour, it'd be $9 for the hour plus $4 for the shoe. That's why you see a $13 here, right? This is $9 for the hours plus $4 for the shoes. 2 hours would be 2 hours at $9 per hour is $18 for the time, right? 2 times 9 is $18 for the time, plus $4 for the shoes is $22. At 3 hours, it cost me $27 for the time, right? 3 hours times $9 per hour is $27 for the time, plus $4 for the shoes is $31. And here, 4 hours times $9 per hour is $36 for the time, plus 4 for the shoes is $40 for those 4 hours. So let's find the COP then. Y divided by X, 13 divided by 1 is 13. Right? This tells us it costs $13 per hour. Which makes sense, right? $9 per hour plus the $4 for shoes, that's $13 total dollars for that hour. But at the second hour, 22 divided by 2 is 11. So if you go for 2 hours, it's going to cost you $11 per hour. That's a changing ratio there, right? It's not a constant ratio. That third one's also going to be a little different, right? 31 divided by 3, that's 10.33. 40 divided by 4 is 10. So you'll see these are different or changing ratios. For that reason, it is non-proportional. Right? There is no constant COP. Okay, so at the very end, at 4 hours, if you go for 4 hours, it ends up going to cost you $10 per hour. The reason for that being that over time, right, the cost of your shoes becomes cheaper and cheaper per hour, right? You're always going to pay $4 for those shoes. Over more time, it costs less per hour. But we move on. The photo developer charges 25 cents per photo developed. Is the total cost going to be proportional to the number of photos developed? Let's create a table to help us out here. We're going to look at the number of photos and compare it to the cost. So one photo, if I get one photo developed, let's see, 25 cents per photo, that's going to cost me 25 cents, right? One photo costs 25 cents. If I got two photos developed, they'd each cost 25 cents, so that'd be a total of 50 cents for two photos. Three photos, let's think. Three photos at 25 cents a piece would make that 75 cents for those three photos. And if I got a fourth photo developed, right, 4 photos at 25 cents each, that's going to cost me $1. So let's find our COP, see if it's a constant ratio or not by doing y divided by x. 0.25 divided by 1 is 0.25. 0.50 divided by 2 is 0.25. Y divided by x, y divided by x. You can see that it is a constant ratio. There is a constant of proportionality of 0.25. Right? That makes sense because each photo is going to be the same, right? They're each 25 cents per one photo. That's our unit rate. So our COP is 0.25. Our equation then would be y equals 0.25x. Y being the cost, right? And x being the number of photos. So this last one here. A soccer club has 15 players for every team, with the exception of 2 teams that have 16 players each. So every team in the league has 15 players, except 2 of the teams have 16 in them. Is the number of players going to be proportional to the number of teams? Let's create a table. We're looking at the number of teams compared to the number of players. Okay. So if I have 1 team, 2 teams, 3 teams, 4 teams, 5 teams. Let's take care of those 2 teams that have 16 players each first, right? If I have 1 team, there will be 16 total players in the league. My second team also has 16 players, so there will be a total of 32 players, right? 2 teams, each has 16. 16 plus 16 is 32. My third team, right, and every team after that is going to have 15 players. So my third team is going to add 15 players to this. So we add 15 players to our list. There's now a total of 47 players. Add 15 more. We'll be at 62 people. Right? If I add 15 more players to this, I'll be at 77. So is the number of players going to be proportional to the number of teams that there are? Let's take our y's and divide them by our x's. 16 divided by 1 is 16. 32 divided by 2 is also 16. So far, so good. But when I get to this third one, 47 total players divided by 3 teams Now there's 15.6 players per team. How about 62 divided by 4? Now there's 15.5 players per team. 77 divided by 5, 15.4 players per team. So you can see it's not a constant ratio. This is a non-proportional relationship because our constant ratio is not actually constant, it's changing.